If we focus on a hydrogen ion, which is just a single proton, because it's continually in motion, they move in such a way, which we tend to call spin, that they produce their own magnetic field. So if a proton is spinning in this direction, now this is heavily oversimplified, it creates its own magnetic moment in this sort of orientation. And these magnetic moments can be random, like if you drop some bar magnets on a desk, they would all point in random directions. So when this proton is subjected to an external magnetic field, which we call B0, it will align, which we'll call the alpha spin state, which is a low energy state, a bit like the electrons in the ground state versus the excited state, which is where they prefer to be. Get them going against our external magnetic field is going to take a bit of energy to get it there. This is a higher energy state, and we'll call this the beta spin state. Think of it like a compass needle. Due to Earth's magnetic field, the needle always points north, and this is almost certain it will happen, this being the lower energy state. However, if you were to flip the needle, pointing it in the opposite direction, you have to physically force it to flip. This required more energy to do so, which is a higher energy state. This energy difference between the lower and higher energy state can be quantified by detecting the difference. So how do we force this proton to move from the alpha to the beta spin state? It's going to require a very precise amount of energy that falls in the radio frequency range. Let's say we do know the exact frequency and hence energy required to flip the proton to the beta spin state. This will be absorbed by the proton and eventually emitted when it returns to the alpha spin state. This frequency will be detected and plotted with information kind of regarding the radio frequency, well not really, versus how many protons require that exact frequency to flip. And since protons in organic molecules share their electrons differently due to the geometrical differences of molecules and electronegative atoms, the protons all require very precise radio frequencies to make them flip. Another concept we need to be aware of is shielding and the chemical environment, but that will be on another video.